3.2. It's called systems of linear equations in 3 variables. So this section isn't hard. You just have to be really, really careful. If you make a mistake, it's going to make things difficult for us. So just make sure you're careful. When we're doing systems with 3 variables, the strategy is to go from 3 equations with 3 variables down to 2 equations with 2 variables down to 1 equation with 1 variable. And then you just plug it in. So that's kind of the game plan. Let me show you what that looks like when we're doing these problems. Okay. Let's start off with a problem like this. The directions are just going to be to solve. And let's say we had x minus y is equal to 6. 2y plus 5z is equal to 1. And 3x minus 4z is equal to 8. Just so you know, I know we have aspiring engineers here. When we have 3 variables, you don't have to know this, but just I think it's interesting. You generally have an x and y plane here. If you were going to have 3 variables, the z-axis would look like this. Imagine if it's like coming out towards you. So if you were to graph something in 3 dimensions, just take like a cube. You can kind of see how it goes back in the axis, so it adds depth. So those are 3 dimensions. Does anyone know what the 4th dimension is? So you have length, width, height. 4th dimension, does anyone know? It's time. So time. All right. You don't have to know any of that. I just figured I'd let you know in case you didn't. And time. That's right. X, Y, Z, and T. What's that? I thought it was wrong. Yeah. X, Y, Z, and T. So you don't have to, again, this isn't important for this class, but that's how you would write them. So how do you do a problem like this? First thing I would recommend is that we line up the variables. So what that means is we have an x minus y is equal to 6. We have 2y plus 5z is equal to 1. And we have 3x minus 4z is equal to 8. Somehow we want to go from 3 equations, 3 unknowns, to 2 equations and 2 unknowns. So does anyone have any suggestions how we can go from these 3 equations to just 2? If we combine the second and third, what we get is 3x plus 2y plus 1z. And we really want to have 2 equations with 2 variables. So what I would recommend is if we could eliminate the z, then what you would have is you'd have an equation with just x and y in it. So if we take Laquan, is that correct? Your name? If we take these two equations, and let's say we multiply the top equation by 4 and the bottom equation by -5. What you'd wind up with is 8y plus 20z is equal to 4. The bottom equation is times -5 would be -15x plus 20, or what did I do here? I want to eliminate the z. So let's multiply the top by 4 and the bottom by 5, not -5. So 15x minus 20z is equal to 40. And if we add those together, we'd get 15x plus 8y is equal to 44. So if we get rid of that z, we have one equation with x and y. We also have the top equation with x and y. So we were successful in going from 3 equations to 2. Now we want to go from these 2 equations to 1. So does anyone have any suggestions on how we could eliminate either the x or the y? If you multiply that bottom equation by 8, you'd get 15x plus 8y is equal to 44. Top equation would be 8x minus 8y is equal to 48. So you get 23x is equal to 92. And then if you divide by 23, you just get x is equal to 4. At this point, it's almost like dominoes. Once you get x is 4, you could plug it back into one of the equations we just used and figure out what y is. So if you plug it in for the x right there, you get 4 minus y is equal to 6. So negative y is equal to 2, and y would be -2. It looks like we have x, it looks like we have y, we just don't know what z is. So we can go back to another equation and plug in for x to figure out what z is. It's almost like a little puzzle we're trying to solve for. So if 3x minus 4z is equal to 8, and x is 4, this would be 12 minus 4z is equal to 8. So -4z would be -4, and z is 1. The answer for this would just be 4, -2, 1. It's always in alphabetical order, x, y, and z. I'll just give you a second to get caught up if you're copying that down, and we'll take a look at another type of problem. All right, what if we had something like this? Let's see here. What if we had x plus y plus z is equal to 2, and then x minus y plus 2z is equal to 2. And then negative x plus 2y minus z is equal to 1. So we have to come up with a game plan for how we're going to proceed here. First thing is we want to go from 3 equations to 2. So generally what we do is we figure out, okay, I'm going to eliminate one variable from the top and bottom from 2 equations, and I'm going to eliminate the same variable in 2 other equations. So just looking at this, if we take these first 2 equations, and what do you think would be an easy one to eliminate? Y, right? If we just add them together, x plus y plus z is equal to 2. X minus y plus 2z is equal to 2. Add them together, you get 2x plus 3z is equal to 4. Okay, so we could either pick the second and the third, or we could pick the first and the third. That doesn't matter. You just can't use the first and the second. So if it doesn't matter, I'm going to pick the second and the third equations. And we have x minus y plus 2z is equal to 2. Negative x plus 2y minus z is equal to 1. And remember, you have to follow your plan. So if we eliminated the y in the first group, we need to eliminate y in the second group. And we'd be able to do that if we multiply this top equation by 2. So we get 2x minus 2y plus 4z is equal to 4. Second one would be negative x plus 2y minus z is equal to 1. Adding them together just gives us x plus 3z is equal to 5. So at this stage, we have 2 equations with 2 variables. The way that you get better at this is by practicing. All right, so just kind of finishing up here, we have 2x plus 3z is equal to 4. X plus 3z is equal to 5. We want to try to eliminate one of the variables. So if we just multiply this bottom one by negative 1, we get 2x plus 3z is equal to 4. Negative x minus 3z is equal to negative 5. So x would just be negative 1. Once we get one answer, then we could just plug in and just figure it out here. So if we know that x is negative 1, I'm just going to plug it into one of these equations. Negative 1 plus 3z is equal to 5. We add 1 on both sides. We get 3z is equal to 6. So z is 2. And then we just have to figure out what y is. So I'm just going to pull one of the equations from the original. Negative x plus 2y minus z is equal to 1. So if we plug in negative 1 for x, remember we should use parentheses because it's negative x. So negative negative 1 plus 2y minus z equals 1. And we just want to solve this for y. So 1 plus 2y minus 2 is equal to 1. 2y minus 1 is equal to 1. 2y is 2, so y is 1. The solution would be -1, 1, 2 for x, y, and z. This would be called consistent and independent. We did get one answer. We're almost done. I just want to remind you that it is possible to get an answer that doesn't make sense here. If you were to do this and you get 0 is equal to 5, just like before, we call this inconsistent. Similarly, it's also possible to get 5 is equal to 5. This would be examples of the same line, which we called consistent and dependent. I don't think we need to go over additional examples of those. If you're doing practice and you wind up with something a little weird, just know it's one of those two scenarios. All right.